Hello, this is Mr. Huber. In this lesson, we're going to learn about functions and see how they are represented as rules and tables and some terminology to know about functions. Okay, a function, often represented by a type of an equation, is where we have some inputs, some values we're plugging in for a variable that when we do the calculation, we'll get a value for an output after we do those calculations. Okay, the exact definition of a function is a pairing of inputs and outputs, plugging numbers in, getting numbers out, where every input is paired with exactly one output. Not more, not less, but exactly one. So we're going to see some definitions of functions coming up. That's what makes a function. The domain is the name we give for the set of all the inputs. So if we list out all the numbers that we plug into the function, that's called the domain. And when we plug those numbers in, we get some values out. Those are called the range. So the domain is all of your inputs. The range is all of your outputs. Let's see how we can identify some of these. So first let's look at domain and range. So we have an example here of a table of values, right? We've got some inputs that are the numbers of gallons, and we got some outputs that are the dollars. So how much you'd spend based on how much gas you're buying. All right, we've got this gas pump situation here. So we're trying to figure out the domain. Right? The domain is all of the inputs. So it's just a listing of numbers that make up the values we plug into this particular situation. So the domain would be 10, 12, 13, and 17. The range will be all the outputs. That'd be 19.99, 23.99, 25.99, and 33.98. Okay, those are the outputs, make up the range. The inputs make up the domain. And if you have a number that's repeated in one of your lists, you don't have to write it twice. So if we're writing out the domain and there were 12 in there two different times in our table, we'd only need to write it one time. So we just need to list every number that possibly appears as an input and an output as our domain and our range. Now look at identifying what makes a function. Right? Remember, a function's definition is that every input is paired with exactly one output. So if we see this situation here, we've got, 10 goes to 2. This is called a mapping diagram. So we're mapping 10 to 2. This would be writing the point input 10 to 2. We can make it a table. We could write 10 comma 2 sometimes when we're writing as an ordered pair, an x and a y. Okay. Input 5 goes to output 4. Input 0 goes to 2 and 3. So it is not paired with exactly one output. These two inputs are paired with exactly one output, but this input is not. As long as there's one input that has two different outputs, it would not be a function. So this is not a function because of the input 0 getting paired with 2 and with 3. Right? We look at our second example here. We have these inputs. 0 goes to 0, 1 to 2, 4 to 8, 6 to 12. That's fine. Any number I plug in as an input, I know exactly what I'm going to get as an output. Here, if I said my input 0, you wouldn't know if I had an output of 2 or 3. Here, if I put in a 0, I know I'm getting a 0. If I put in a 1, I know I'm getting a 2, and so on. Every input is paired with exactly one output. So this particular situation is a function. Those inputs and outputs do make a function. Let's have you try that. So on these two examples, look through the inputs and outputs and determine if you think those are functions or not. All right, as we look at these now, number 2, does every input have exactly one output? It does. Okay, this is a function. So we see here that we have an output of 2 and 2. That's fine. Two different inputs can go to the same output, but I know when I plug in a 6, I'm only going to get out a 2. When I plug in a 9, I know I'm only going to get out 2. Every input goes to exactly one output. Okay. If we look at the next problem, right, we've got here, now we've got an input 2. I don't know what 2 goes with. If I put an input of 2, I might get a 0 or I might get a 1. So because here, that input 2 goes to two different outputs, this is not a function. So you want to look and see if every input is paired with exactly one output. That is the definition for a function. Two other terms to know here, independent and dependent variables. The inputs are also known as the independent variable, outputs as the dependent, because the outputs depend on whatever we plug in. Okay? You put an input in to calculate the output. So the output depends on something else. So the outputs are the dependent variable. The inputs are the independent variable. All right. In this example, let's identify a few things. We're going to make a table, and then we're going to see if we can determine what the range, independent, and dependent variable are. So we've got this function here, y equals 2x. As I said, functions are often represented as an equation. This is a function, y equals 2x. And we've got 0, 2, 5, 7, and 8. It says that's the domain. The domain is those numbers. So that's all of our inputs. So when we wrote the equation y equals 2x, we're plugging in numbers for the x. We can change the letters, that's fine. The variables can change, but what we plug in for, that's our input. We're plugging in values for the x and calculating then a y. So our inputs, our x values are 0, 2, 5, 7, and 8. That would be the domain, right? The domain is all of these values. Those are our inputs, x values. So now we're going to calculate some y values. So y is equal to 2 times x. So 2 times 0 would be 0. 2 times 2 is 4. 2 times 5 is 10. 2 times 7. And 2 times 8. So now we've got a listing of outputs. Okay, that's our range. Our range is 0, 4, 10, 14, and 16. Right? That right there, that's the outputs. Okay, our range. Now, independent variable. The independent variable would be the x. The dependent variable is the y. We're plugging numbers in for the x to calculate the y. Right? The y value doesn't exist until we plug something in for x. So it depends on there being an x value. So keep in mind all these different terms. All of the inputs are known as the domain, and another name for those inputs is independent variable. Inputs, independent variable. Okay? The outputs are our dependent variable, also known as the range. Right, before we see some more information about functions, let's talk about glaciers. What do you think makes something a glacier? All right. So glaciers exist in many different parts of the world. Actually, 99% of the glaciers are contained in areas of polar ice caps, the poles of the Earth. So a couple things. A glacier typically doesn't have to be, there's no set definition, but the general standard is that it's at least 25 acres in size. Okay? And a glacier is an accumulation of snow and crystalline ice that's compacted down over time, and after it gets to a certain size, it becomes a glacier because it actually moves. To be a glacier, it's got to be moving. It moves very slowly, but that gravity and that pressure carries it through the earth, picking up sediment along the way, and you see a couple examples there. You can see here this glacier that's flowed down through here, right, and gets to that edge, so where the water is located. And glaciers can get up to 1,500 meters in thickness. So again, a glacier is a moving body of compact snow and ice that, under its own gravity, does actually flow. Right? And it's usually at least 25 acres to be able to get to that standard. All right. Let's write a couple rules for these functions. So we can see here inputs and outputs. We want to write a function, an equation, right? So when we talk about a rule, right, that's a number, an equation is another name for that. We could use whatever variables we want. I'm typically going to use y and x. You don't necessarily have to, okay? But we want to see, how does the output depend on the input? What do I have to do? What calculation is occurring here? So I want to figure out, how am I going from this input to this output? How am I going from this input to this output? And it should be the same thing for the entire set of values. Okay, no matter what I do to the input, I should do the same thing all the way through to get those outputs. So sometimes you might have to try. Maybe you have to add something, divide, multiply, whatever it might be. In this case, to go from the input to the output, I'm adding 2. So my rule would be y equals x plus 2. Right? And we could test that. We could say, let's plug a 4 in here. If I take a 4 and substitute it in and evaluate, I would do y equals 4 plus 2, which is 6. 4 plus 2 is 6. And it should be the same for all of them. I can check 10. I plug a 10 in. 10 plus 2 is 12, my output of 12. So we can see that it works for that particular table of values. All right, you try number 6. See if you can come up with the rule for that and see how you did on it. All right, for number 6 here, we want to look through, and this again you might want to test. Okay, hey, maybe I'm just adding 2 again. 1 plus 2 is 3. But if I go here, 2 plus 2, I don't get 6. 3 plus 2, I don't get 9. So it's not adding 2. right? I've got to be able to do the same thing for every input to get that output. So I look, okay, what else might I be doing? See what you might subtract or divide or multiply. All right, 1 times 3 will give me 3. 2 times 3 is 6, 3 times 3, and so on. So yes, I'm multiplying by 3. My rule here would be y equals 3x. I'm taking my input and multiplying by 3 to get that particular output. Let's check one other situation here where we're going to kind of tie all of this together. We're going to make a table of values. We're going to identify those different variables, domains, ranges, write a rule. So let's see here what we can do for this particular situation where you're buying concert tickets. Okay, they cost $15. All right, you can buy up to 6 tickets, so there's a limit there. We're going to write an equation, which is our rule for the amount you spend as a function of the number of tickets. So first I'm going to define some variables. You can use y and x if you want. Just always say what they are. So if y is the total cost, okay, and x is the number of tickets, all right, those are our two variables. We're going to find some number of tickets we're buying and get a total cost based on that, right? So we're going to take each ticket we buy and multiply it by $15. So our equation, our rule for this particular situation is be y equals 15x. And so we can make a table of values for that. So we make a table of values here. Okay, we're going to have our x and our y. We could buy 0 tickets, we could buy 1 ticket, we could buy 2, 3, 4, 5, or 6 tickets, right? And our cost is going to depend on how many tickets we buy. So if we buy 0 tickets, it costs us $0. 1 ticket costs us 15 times 1, 15 times 2, and so on, right? Each number of tickets we buy is an extra $15, right? All the way up to if we bought 6 tickets, the limit, we would spend $90. So that's our table of values. So we've made a table of values from our equation, make sure we know what our two variables are, and now let's identify the independent dependent variables, the domain and the range. Okay, so our independent variable, okay, the independent variable is going to be the number of tickets we're plugging in. This is the independent variable. Okay, our total cost then depends on it, the y value, the total cost. That is our dependent variable. Right? It depends on how many tickets we buy. We don't have a total cost unless we know the number of tickets. Right? Total cost depends on the number of tickets that we make a calculation from. Right? Our domain and our range. So our domain is going to be all of those x values. So domain is 0, 1, 2, 3, 4, 5, and 6. Right? Those are the different number of tickets we could buy. Those are all the possible inputs. Those are the only numbers we could put in to that equation. Right? We can't buy more than 6 tickets. We can't buy 2.5 tickets. We can't buy negative tickets. We can buy 0, 1, 2, 3, 4, 5, or 6 tickets. And our range then is all of those outputs, which would be 0, 15, 30, 45, 60, 75, and 90. Okay, and remember, the range, those outputs depend on the x values, right? The only way we get those y values is based on having x value to plug into our equation. So the domain is all of the inputs, the numbers we're plugging in. Those are our independent variables. They can be, in this case, any of those numbers, 0, 1, 2, 3, 4, 5, or 6. The range is all of the outputs, the dependent variables, the numbers we get from those calculations after we plug something in. And then also remember back to what a function is. A function, this is an example of a function because every input has exactly one output that it's paired with, right? No matter what I plug in, I know exactly what I'm going to get out. So a lot of terminology know the different terms, what they relate to, how they relate to one another as we continue to learn about functions, looking at them as rules and tables, inputs and outputs, domains and ranges.